We're going to continue number theory, focusing on the GCF, the greatest common factor, and the LCM, the least common multiple. Let's first focus on the greatest common factor. Remember, common factors, if we're dealing with two numbers, we're finding the factors that are going to be the same. So there can be more than one pair of common factors, but this is going to be different than saying the greatest common factor. The greatest common factor is going to be the largest of all the common factors. Finding the greatest common factor, you're going to go ahead and write out all the factors of the number, especially when I tell you to identify the prime factors. Now you're going to have to do your prime factorization tree. So you will first find the prime factorization of the numbers. You're going to identify or circle the common factors. And then if there's more than one common factor, you're going to go ahead and multiply them. Now this is specifically when we're doing the prime factorization tree. If we're writing out all the factors, now when doing the prime factorization tree, number 3 is important. You're going to go ahead and find the common factors, those common numbers, and then you're going to multiply them to come up with the greatest common factor. You can check your work by writing out all the factors, finding the greatest common factor on your own. So here, I am taking 35 and 42 and I'm writing out all the factors. I am not doing the prime factorization tree in this example, in this practice. So if I just write them all out, I can go ahead and look and find the common factors. I can find 1, I can find 7, and that's about it. So 1 and 7. So what is the greatest common factor? Of course, 7. That is larger. So to clarify from what was just said in the previous slide, here is the prime factorization. If I'm dealing with 60 at the top in the picture, I'm going to divide it into 3 and 20. Remember, I'm not doing 1 and 60. I'm looking for the prime numbers here, okay, greater than 1. And then I keep 3 by itself, and then I divide 20 into 2 and 10. Okay, the 2 is then brought down. Okay, and then I divide 10 into 2 and 5. Okay, so that's your factorization tree. Now, if I'm comparing that with two numbers, I'm going to go ahead and break them down, and I'm actually going to identify which ones are going to be similar. So let's go ahead, let's do some practice for the prime factorization. Let's do 40 and 100. If I take a look at all my factors, I can find out that my prime factorization would be 2, 2, 2, and 5. Now, 100 is going to be broken down into 2, 5, 2, and 5. So, or in other words, 2, 2, 5, and 5. Let's find which ones are going to be common factors. If I look there, 2 and 2, so if I have 2 2s and 1 5, those are the common factors. So those are the ones that are going to be the same. Okay, for 40 there are 3 2s being used, but for 100 only 2 2s. So this is what's going to be common. To get the greatest common factor from doing the prime factorization, I'm now going to multiply those. 2 times 2 is 4. 4 times 5 is 20. That's the greatest common factor. Now, if I take a look at the very top where I wrote them all out, I can see that 1, 2, 4, 5, 10, and 20 are common factors, and I can check my work by writing it all out. 20 would be the largest. So make sure you know, okay, that you're able to do the greatest common factor by writing them all out, but also by using the prime factor tree. I may ask you on assessments to do or identify the greatest common factor by prime factorization. So if I ask you by prime factorization, make sure you're able to do the factor tree. And then when you get your small little numbers, 2, 2, and 5, you find the common ones, and then you multiply. Let's do this again. Let's practice. Okay, practice 3. 42 and 105. Okay, so if I do the prime factorization, I get it for 42, I get 2, 3, and 7. For 105, I get 3, 5, and 7. So what are the common factors? The common factors are 3 and 7. So I multiply 3 and 7. 3 times 7 is going to be 21. And that's my greatest common factor. Because when I have large numbers like 105, that's going to be very difficult to write out all the factors of 105. Okay, let's do another practice. Let's focus on 60 and 90. Once I do my prime factorization tree, my factors for 60 are 2, 2, 3, and 5. For 90, it's 2, 3, 3, and 5. So the common ones are 2 and 3 and 5. So I multiply 2 times 3 times 5, and that gives me 30. Now the word relatively prime or coprime refers to no common positive factors, okay? No divisors. So, and we're talking, of course, except for 1. There are no natural numbers that divides them both. So if I talk about 12 and 13, those are relatively prime. That's because there are no factors in 12 and in 13 that are the same or similar. Okay, and of course 1 in 12 and 1 in 13, the 1 is similar, but we're not including 1. Okay, so there's no numbers that are in 12 that are in 13. So those are relatively prime. But 12 and 14 do have common numbers, such as 2. So they are going to have similar numbers, so they are not relatively prime. Okay, let's look at practice 1. 16 and 27. 16 is going to be divided into 2, 2, 2, and 2 for my prime factorization tree. But 27 is divided into 3, 3, and 3, or 3 cubed. So the focus here is there are no similar numbers, so they are relatively prime. And in other words, the greatest common factor for relatively prime numbers would only be 1. Let's try number 2. Let's look at letter A, 57 and 76. Okay, when I do the prime factorization 3, we have 3 and 19, 2, 2, and 19. Are they relatively prime? No. Why? Because they both have 19 as a divisor. Let's look at 65 and 77. There are no numbers that are the same. Okay, 65 has 5 and 13. Of course, 1 and 65. 77 have 7 and 11. So they are relatively prime because there are no numbers that are the same when I do my factorization tree. Now let's focus on the least common multiple. Remember, we talked about multiples before, and this is like 2, 4, 6, 8, 10, 12. Those are multiples of 2. Multiples of 10 would be 10, 20, 30, 40, 60, and they move on and go on for eternity. So the least common multiple would be the smallest. We're going to bring it back as close to the number as possible. So what is the least common multiple of 4 and 6? Well, here's some written out to you. You can see the circled ones are common multiples. We have 12, 24, and 36. But which one's the least common, the smallest, closer to 4 and 6, would be 12. Now, with the least common multiple, when we do the prime factorization, you're going to take the number, do the prime factorization, circle the highest power of each prime number, okay? Then you're going to find the product of the highest power of each factor, prime factor. Let's look at some examples. Find the common non-zero multiples of 4. If I write out the multiples of 4 and 6, I'm going to find 12, 24, and 36 are going to be common multiples, but 12 is the least common. For 6 and 9, the least common is going to be 18. Now for practice 3, we have more than 2 numbers I'm looking at for the least common multiple, and I can actually identify the common ones, such as 30, and that's about it. So 30 would be the least common, the only one that I'm seeing for the first 4 to 5 non-zero multiples. Now let's take a look at practice 4 and 5. You can see the practice 4 and 5, I'm actually looking at the prime factorization. Okay, find the least common multiple of 25 and 55. This is for larger numbers. I'm going to do the prime factorization. I'm going to divide 25 into 5 and 5, 55 into 5 and 11. So my least common multiple for 25. So for practice 4 and 5, this gets a little trickier. This is why it's important to follow the rules on the previous slide or the previous slides dealing with prime factorization. So first I'm going to take 25 and 55. I'm going to do the prime factorization for it. So 25 is 5 and 5. 55 is 5 and 11. Now the second step, it says to circle or identify the highest number. Now here I have 5 and 5. It's the same number. Both of them are the same. So I can go ahead and multiply those and identify it as 25. Okay, because 5 squared is going to be 25. So because 5 is the same number, 5 squared will be that highest number. So I have 25. Then let's look at 55. I have two different numbers here, 5 and 11. So I'm going to circle the highest number here, and that's going to be 11. I'm then going to take those two numbers, 25, which is 5 squared, and multiply that by 11. Okay, this is dealing from the rules, or coming from the rules on the page, the slide that's 2 pages before this. So 25 times 11 is going to be 275. So let's do this again. Let's try this again. Okay, we have 9 and we have 12. Okay, let's do the prime factorization. 9, I can break it up into 3 and 3. 12, I'll break it up into 2, 2, and 3. So I'm going to look at the largest numbers here. Okay, 3 times 3, I can turn that into 3 squared because 3 and 3 would be the same number. I'm going to make it 3 squared, so the number will be 9. Now we have 2 squared and we have 3. Remember, 2 times 2, 2 and 2 is the same, so I'm going to combine that. 2 squared is 4. 4 and 3, okay, 4 would be the larger number, okay, so I'm going to multiply 9 times 4. 9 times 4 is going to be 36. Now, if you're having difficulty with prime factorization when dealing with the least common multiple, please come to the study session. We can talk about it. I can also go over it right before the quiz on Thursday.